All right, so we've gotten to long division of polynomials. Looks cumbersome, but it is just as simple as regular long division. If we remember what dividing polynomials looks like, we'll realize that anything over itself is going to be equal to 1. And when we see something more complicated like 72x squared minus 8x over 8x, we might see that negative 1 in the negative 8x over 8x. But what do we do with the 72x squared? Well, we just break it down bit by bit. 72 over 8 is equal to 9, and x squared over x is equal to x. And so what we'll end up with is 72x squared minus 8x over 8x is really just 9x minus 1, as long as the x value isn't equal to 0, because then that would make that 8x in the denominator 0, which would make it undefined. So there's your little bit of review, but let's go back to the main start of the show here, long division of polynomials. Well, I'm going to see a problem right here, and I'm going to want to divide these two, and they look it looks very difficult, but as long as we put it into long division, it becomes quite simple. And the way that we do is we just write this out the way that we would this would have been the numerator, this would have been the denominator. We'll see that later on in this one. And we put them in descending degree order, x to the third, x to the second, x to the first, and then our constant. After we do that, we take a look at this first term in the binomial, and we're going to look to see, what do I have to multiply x by to get to x cubed? Well, it's going to be x squared, but once I take this x squared and I multiply it, I'm going to multiply it by the whole binomial, and in order to so I've got to multiply x squared by 2. So I'm going to have x to the third plus 2x squared. Once I do that, I'm going to write that whole distributed answer down here. I put it into parentheses and put a negative on the outside, because we know that in long division, whatever we come up with is going to be subtracted. Now, sometimes in class I'll write the cancellation mark right there, but what you really need to remember is that this sign changes because that becomes distributed, and that's the reason why I put it the way I have here. So this is really negative 2x squared. So positive x squared, negative 2x squared results in negative x squared. We just, in regular long division, we just carry down the next term. The next term here is negative 8x. So now the question becomes, if you see here, what do I have to do? What do I have to multiply x by in order to get to negative x squared? Well, it's going to be negative x. But once I multiply negative x, if you see over here, negative x, we have to distribute it across the whole binomial. We get negative x squared minus 2x, which is what I've written right here. And then I've reminded myself that the signs are going to change, so these two can cancel out. And so this is going to be positive 2x. So negative 8x plus 2x is going to be negative 6x. And then finally, we're going to look here and say, well, what do I need to multiply x by in order to get negative 6x? And it's going to be negative 6. We come out with the exact same two terms, and therefore we know that both of these are going to cancel. We get 0. And that tells me that if I multiply this times this, I'll get this. So these are both factors of this larger polynomial. And if we even look at this, we'll say, oh, well, this can be factored further. I see the coefficient on the x squared term is 1. And as a simple quadratic, you guys know that you just look at the constant and say, what are the factors here? I see that this is negative. Therefore, one of them is going to be negative and one's going to be positive. And the bigger one is going to be negative because that middle term is negative. So that's how I came up with the negative 3 and the positive 2. And here you'll see them, negative 3, positive 2. And all this is a fully factored version of this larger polynomial. Okay. But sometimes you're going to be given something that looks like this. And we understand that a fraction is a division problem. But we also see that I'm missing some of my degrees. I'm missing x to the second and x to the first. Well, let's see if we can divide this number by that number. And once we take a look at it, we'll see that as long as we've written in all of the degree values, we've got to fill them in if they're not there. Because once we start doing this long division, we're going to have to make place for them because we're going to end up with the distributed components. So here we are. Let's look at these leading factors. X to the third. How do I get there from x? Well, I multiply by x squared, but I'm going to have to not just come up with x cubed, I'm going to have to multiply this by 2, so it's going to be plus 2x squared. I remember that this whole packaged up binomial gets subtracted, so this is a negative now, and that's how I come up with negative 2x squared. How do I get to negative 2x squared from x? Well, I multiply negative 2x by it. And once I multiply the whole thing and distribute it across that 2, I get negative 4x as well. And this whole package again gets subtracted. These guys go away. And this becomes a positive 4x. We bring down that last term, and then we know that this also will resolve perfectly. So here we have a good answer for something that looks complicated. We might be able to factor this again, but I'm not going to right now. If this was a function also, we'd also have to reconcile the fact that there's an excluded value here where x can't be negative 2 because again that would make this undefined. I hope that helps.